We are graphing tangent of x and his friend, the reciprocal cotangent. Hey, this is the third video where I'm graphing the trig functions by hand. So hopefully you've already watched the sine of x and the cosine of x and their reciprocals. But now I'm going to attempt to graph the tangent of x and the cotangent of x both by hand. But keep in mind, I'm doing this with very basic knowledge of the unit circle, the 4 points on it, and understanding a little bit conceptually what the tangent is. So to make this video a little bit shorter and maybe a little less painful, keep in mind that at 0 radians, tangent is 0. Sine over cosine, so that would be 0 over 1, which is 0. So let me go ahead and plot that point right there. The problem comes in when I get up here to pi over 2 radians. I am at 1 over 0, which is undefined. So let me draw in that asymptote right there. And the same thing's going to happen over and over again. Once I get to pi radians, I'm 0 over -1, which is 0. And then once I get right here, I'm at -1 over 0, which is undefined. And then I'm back at 0, then another asymptote, and I can repeat this over and over and over. And not to get and lose anybody, but if I go to negative pi over 2, that's just going this direction on the unit circle. That's -1 over 0, which is undefined. So keep in mind, let's not make too much of an issue with this. 0 over 1 is 0. 0 pieces of candy to divide amongst one child. How many pieces does each child get? 0. Okay. And 0 over 1 over 0 is undefined. 1 piece of candy divided amongst 0 children. How many pieces does each child get? That seems kind of weird. So no, that is not okay. It's undefined. So now that we have this, what happens next? So tangent goes from 0 all the way around the unit circle to something that is undefined. What does that mean, undefined? And see, this is where we kind of get into some calculus concepts, but let me just say this. Undefined, and I'm going to get a lot of mathematicians up here, they're going to be groaning, but keep in mind who this video is intended for. I want my daughter who's 8 to get some enjoyment out of it. My other daughter that's 12 will know what's going on, but my trig students, look, undefined. Let's just say 10 divided by 10 is 1. 10 divided by 5 is 2. 10 divided by 1 is 10. 10 divided by 0.1 is 100. So as my denominator gets closer and closer and closer to 0, my quotient's getting larger and larger and larger. So if somebody said, hey, if 10 divided by 0 was going to be something besides undefined, what would it be? The average person would probably go, well, 0. No, a billion, a trillion, a quintillion. It's going to get big. This is a big angle side number. I'm telling you, it's really big. So with that in mind, as we approach undefined and asymptote, we're getting large. Now, if you don't like that, what I just said, well, let's look at it from the perspective of triangles. At 45 degrees, the tangent is 1 over 1, which is 1. So halfway between 0 radians and pi divided by 2 radians is pi divided by 4 radians, which is 45 degrees. So we should be at 1. What happens next? Well, let's look at this triangle. The tangent of theta right here is opposite over the adjacent. Small over large is a very small number. But as this angle gets bigger and bigger and bigger, as it approaches 90 degrees, look what happens to the tangent of beta. It is a very large number over a very small number, bigger. So it happens there, it happens here, it happens here, and what happens is we go from this direction to that direction. We're going from 0 to undefined on the negative side. So we are just like this. And when the little boy asked the math teacher how long this would go on for, he said, forever, forever, forever. So there we go. We got it right there. So now, what's going to happen with the secant? The secant is the reciprocal. Did I say secant? Ooh, it's been a long morning. is the reciprocal of tangent. I would not expect anybody to graph the secant, the cosecant, or the cotangent without thinking about the reciprocal functions first. So the graph of the cotangent, let's look up here. Everywhere I've got a 0, I should have, ooh, I almost marked myself. I should have an asymptote where it's undefined. The reciprocal of 0 is undefined, right? 0 divided by 7 is 0. The reciprocal, 7 divided by 0, is undefined. So here we have another asymptote. Here we have another asymptote. Right here we have another asymptote. And right here we have another asymptote right there, which is awesome, which is very cool. Oh, what's the reciprocal of undefined up here? 0. So wherever there's an asymptote here, we have 0. Wherever there's an asymptote here, we have 0. So now we're saying, well then, how do we finish this graph? It's a tiny bit tricky, but it's not. It may confuse people, but it shouldn't. Watch. In order for me to get the graph between this asymptote and this asymptote, if I move up, I've got to use this piece for here and this piece for there. That's the only part that may be mildly confusing. I can't just take this and think about it down here. What I need to do is say, well, what's happening between these two asymptotes, and it involves these two pieces of the graph. So here we are increasing, which means down here we should be decreasing. And then from here to here we're increasing, which means down here we should be decreasing. So there it is, right there. Let me do it one more time. On this little stretch right here, I'm using this, I'm increasing, which means my graph should be decreasing. And then at this piece right here, I'm increasing, which means that is decreasing. So we get this type of scenario right here. And if you look at it very carefully, there's some interesting pieces. Obviously, the domain for both of these functions is not all reals, because there's some massive breaks in them. So keep that in mind. Right? Yeah. The range, how interesting. The range on both of these graphs seems to be from negative infinity to positive infinity, all real numbers. That's very cool. But what's more interesting about these two graphs are their periods. How often do they repeat? So if we look at this, we go from negative pi divided by 2 to pi divided by 2. It repeats over and over every pi radians, every 180 degrees. And you're saying, how is that possible? Why is tangent so different from all the other ones? Well, let's go back to the unit circle. All students take calculus. Tangent's positive here and here. So from 0 to 180 degrees, from 0 to 2 pi radians, we hit all those positive values, and then we hit all those negative values in only 180 degrees. We don't hit them, well, we hit them all again from here, all positive, all back to negative. So there's a weird symmetry vibe to, whereas to the tangent. So the period for both tangent and cotangent, they repeat every 180 degrees, every pi radian. There you go. The graph of this and the graph of that. How cool is that? We have graph tangent and its reciprocal function cotangent of x.